Okay, we're going to use, we're going to write some more half equations and then use those two half equations, put them together and write a full equation. Some more practice of this. Okay, so the reaction we've got here is we've got potassium iodide, which is a colorless in the water, in a colorless solution. And actually we were also going to add a little bit of hydrochloric acid to that as well. You'll see why in a minute. And then we've got some sodium chlorate 5. That should give you a clue to the oxidation number of chlorine there. It is +5. Okay, so you mix those two solutions together, you get a reaction occurring. It goes dark brown because you made some iodine. Okay, and the chlorate, well, look, that ends up being as chloride ion. Okay, so we're going to use our rules here to write two half equations and then combine them together. Right, let's do the iodine one first. That's pretty straightforward. Okay, so we're going to have, we've got Ki there, haven't we? But we're not going to, we know that it's going to be K plus and I minus, and the potassium is going to be a spectator ion. It's not going to do anything in this reaction, so I'm just going to write down I minus, and that's going to get oxidized to diatomic iodine there. Right, first of all, balance for the element of interest, right, which is iodine. So we do need to put a 2 in front of that there. Balance for oxygens, we don't need to do anything. It's only balance for hydrogens, don't need to do anything. Balance the charges, yes, we do need to do that. Got 2 minuses on the left and 0 on the right, so we've got to put 2 electrons in there. Finally, check your oxidation numbers. So -1 for iodine there, and it's going to be 0 for the element. So -1 to 0, it's gone up, it's been oxidized, oxidation is lost. Have we lost the you are losing electrons? Are we losing the right number of electrons? We're losing 2. Well, we've gone from -1 to 0, which is 1 electron only, but there are 2 atoms, so that is 2 is the right answer there. So that equation is complete and checked. Let's do the chlorate. What happens to the chlorate one? Okay, so here we have sodium chlorate. Again, we have got a group 1 ion here, Na+. So we know that that is going to be ClO-. We're not going to worry about the Na because it is a spectator ion. So here we go, ClO-, and that is going to turn into the chloride ion. Sorry, ClO3, 3. Right. So 1, balance the element of interest. 1 chlorine on each side, so that's fine. 2, balance the oxygens, so we need to put 3 H2O there. There's 3 oxygens on the left. Number 3, balance the hydrogens by adding H pluses, so we want 6 H plus there. 4, balance the charges. So on this side of the equation, we have got 6 plus, and that's -1, so that's +5. On this side, we've got -1, so that means we need 6 electrons on this side to make it the charges balance. Okay, then we'll finally do our check of oxidation numbers. Well, this is the chlorate 5 ion, which gives away the game really, because that means it's a +5 oxidation state. And if you wanted to work it out, sigma oxidation numbers is equal to the charge. The charge is -1. Chlorine we don't know. 3 times oxygen -2, -6. So chlorine is going to be +5. So that's fine. And the chloride ion is obviously going to be -1. So it is a reduction because the oxidation number has gone down. So reduction is gain. Is it gaining? It is gaining electrons. Is it gaining the right number? Well, from +5 down to -1 is 6. So that is the right number of electrons. So that's all good. Then we've got to combine these two half equations together to form a full equation. Right, this one gives away 2 electrons. This one uses up 6. So we're going to have to times that one by 3 and then add them together. So I'll write down the final equation here in blue. So we need 6I minus, 1 chlorate ion, 6 H plus ions. The electrons are going to cancel out, so we're going to leave them out. And you need to times this by 3, so it's 3I2. And it's going to be Cl minus and 3 H2O. So that is our final ionic equation. And then if you don't like ionic equations and you're a bit suspicious of them still, well, let's just check. Let's look at the spectator ions. Well, the spectator ions for this is going to be, you're going to have 6K pluses, yeah. That you're going to have a 1Na plus. The H pluses come from hydrochloric acid, so it's 6Cl minus. So if I so you can see on the other side of the equation, these are going to form potassium chloride. So you would write 6Ki plus sodium chlorate 5 plus 6HCl goes to 3I2. This Cl is where you can consider that's being like NaCl, and then you've got these 6 KCl's here and 3H2O. But as I say, the real equation that we're really interested in is just this blue one here. Yeah, that's what you want. That tells you everything. Now, the next bit of the video is just for you to have a go at using these rules, these 5 steps to balance some half equations. So I've got some half equations ready that I did earlier here. Right, here they are. Right, so we have got 10 half equations for you to balance. I'll just get that. Okay, so I've got 10 there. Now, I need to not reveal the answers because they're just below. You got 10, so pause the video now. Complete those half equations with the 5 steps, and when you've done them, stop pausing the video, play it, and have a look at the answers, which I am now about to reveal. So if you haven't done them yet, press pause before you spoil the fun. And here are the answers. Okay, and in the blue numbers above, I've just written the oxidation number of the element that's been oxidized or reduced. Yeah, okay, there. Okay, so we'll end the video there.